Okay, now we're going to look at how to do a test for independence. And we talked in our first lesson about independent events. So how can we test for that with conditional probabilities? So in our example 3, we have the table below shows the vehicles in a parking garage one afternoon. So if we just look at the table, you can see we've got cars, vans, pickup trucks. We've got how many total cars, how many total vans, how many pickup trucks. And then we've got colors. We have red vehicles, black vehicles, or white vehicles, black vehicles. We've got those totals. Um, and this total 22 is how many total vehicles are in the parking garage this particular afternoon. Okay, so a vehicle in the garage will be selected at random. Let B represent the vehicle is black, and V represent the vehicle is a van. Of course, they had to pick letters that rhyme, but we'll go with it. B and V, hopefully I can enunciate that well enough. Are events B and V independent or dependent? So is, choosing a vehicle that is black and choosing a vehicle that is a van, are those independent events or dependent events? So there's a test that we can do. So let's put a little star, test for independence. Basically, we're testing to see if events are independent. So if events A and B are independent, here's our little rule. Then the probability of B given A will be equal to the probability of B occurring, and also the probability of A given B will be equal to the probability of A occurring. Okay, so there's our test. Let's 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 test it. Let's put it to use. Let's whatever I'm trying to say here. Okay, so here's the question we're trying to ask. Does the probability of choosing a black vehicle, given that it's a van, equal the probability of choosing a black vehicle? That's what we want to figure out. Um, that's just kind of using this first one right here. Well, I guess I'll come back to that. So let's see what this is. So this right here is a conditional probability. We have a formula for that. That's just doing the probability of that the vehicle is black and a van divided by the probability that the vehicle is a van. So let's take a look at our chart up here. How many vehicles are vans and also black? There's 3 of those. Out of how many total vehicles? 22. So we have 3 out of 22. We're going to divide that by the probability of choosing a van. So here's our vans. We have a total of 3 vans out of 22 total. All right, so normally I would multiply by the reciprocal, but what I'm noticing is 3/22 divided by 3/22. Anything divided by itself is 1. All right, so that 1, that's kind of significant. That's 100%. So this conditional probability right here is 100%. What's the probability of choosing a black vehicle given that it's a van? So first it has to be a van. If you notice, of the vans, all we have are black vans. We don't have any other options. That's why that was kind of unique, that that was a 100%. But we're just going to follow our rule. Now, what's the probability um, of choosing a black vehicle? So how many black vehicles do we have? 13 total out of 22. And in our test for independence, the probability of B given A, which is 1, would have to be equal to the probability that B occurred, 13 over 22, and we can say that they are not equal to each other. So what that means is that the events are not independent. Which means they are dependent. Let's say that we did this math and this actually was true. They were equal to each other. Then what we would do is we would come up and test the second part of our test for independence, because this would have to be true also. This is true and this is true, but because we tested the first one and it wasn't true, the probabilities were not equal to each other, we didn't have to bother with the second one. But normally, for the events to be independent, we have to meet this criteria and this criteria.